The end behavior of a polynomial will act like a power function. Find the leading term in each of the polynomial functions to determine the end behavior of that graph. So for example number 48, we're looking at f of x equals 4x to the fourth plus 7x minus 3. The leading term, remember, is the one with the biggest power when it's in standard form. So our leading term is 4x to the fourth. The end behavior of 4x to the fourth is the same as the end behavior of my polynomial f of x. So the leading term, 4x to the fourth, tells me that the left end is up and the right end is up. So if that's true for 4x to the fourth, then it's also true for that polynomial there. And you can test that out. You know, you can type in the function 4x to the fourth plus 7x minus 3. Take a look at that graph, and we would expect both ends to be up. Now, it doesn't look exactly like 4x to the fourth, the graph, but both ends are going to be up. So if I type in 4x to the fourth and graph it, it doesn't look like it's so much in the middle, but the ends are lining up nicely. The left end is left end is up and the right end is up. So for letter B, again, this one is not written in standard descending powers of x form, but I can pick out what the largest power is by looking at the term negative 6x to the fifth. That's the biggest power, the biggest exponent in all of the function here. So negative 6x to the fifth, I can identify what the end behavior is going to be. My left end is up and my right end is down. And again, you could type it in and take a look. Sometimes I'll have students go, well, why don't you just type in the function and take a look? Well, sometimes the function is really jammed up on your screen of your calculator and you can't really tell what the ends are doing. But if you type in just the leading term, you're definitely going to be able to see what your ends are doing. For letter C, it's not in standard form. This is all multiplied up here. So I'm going to have to think about what would the leading term be if I multiplied it all out. So here's a little something you can think about. X plus 2 raised to the fourth power. I'm going to write it out. X plus 2, 4 times x plus 2, x plus 2. And x minus 1, the quantity squared, is x minus 1 times x minus 1. If I multiply all of the leading terms in each of the factors together, I'm going to have negative 8 times x times x times x times x times x times x, or negative 8x to the sixth, 1, 2, 3, 4, 5, 6 power. That would be my leading term if I were to multiply all of this out. I don't want to, but that's what the leading term would be, which tells me what my ends are doing. Left end down, right end down. And the reason they're both down or falling is because it's an even degree, which means the ends are going to do the same thing, and its negative coefficient, negative 8, tells me that they're both going in the negative direction. Right. The next set of directions is asking me to find the x-intercepts or zeros of a function. Hint, let y equal 0 and solve for x. These are factored, so my first function, h of x equals 2x times the quantity x minus 1 cubed times the quantity x plus 4 squared. I'm going to set the function equal to 0, then set each factor equal to 0, solve for x. So 2x rather, I'm going to set equal to 0. Divide by 2 to both sides. X equals 0 is 1 x-intercept. X minus 1, the quantity cubed. I'm just going to set the factor x minus 1 equal to 0. I don't have to worry about the power 3 right now because that just tells me that x minus 1 would have shown up 3 times as a solution. X equals 1 then, showing up 3 times as an answer, is also an x-intercept or a 0 of the function. X plus 4 squared. I don't need to put the power of 2 on there because that's just saying x plus 4 times x plus 4. And if I set each of those factors equal to 0, I would get the answer x equals -4 twice. All right, so I don't have to worry about the power right now. I just need to solve for x. So I have 3 different x-intercepts here, 0, 1, and -4. All right, for letter B, all right, we're going to find the x-intercepts. So let y equal 0, -8, x plus 2 to the 4th, x minus 1 squared. Set each factor that has an x in it equal to 0. The -8 doesn't have an x in it, so I'm not going to set that equal to 0. The -8 tells me that it got flipped and stretched by a factor of 8, but it doesn't tell me anything about the x-intercept. In order to do that, I set x plus 2 equal to 0, solve for x, and recognize that power 4 just means that that number -2 would have shown up 4 times as an answer. Same with x minus 1. Set that equal to 0, solve for x. X equals 1 would have shown up twice as an answer. And that showing up 4 times or showing up 2 times, that's called the multiplicity of the 0. In A, the factor x minus 1 up here showed up 3 times, all right, in h of x. The 0, 1, right, then is repeated 3 times, or we say that 1 is a 0 of multiplicity 3, an odd number. -4, coming right back up here to our letter A answer, x equals -4, is a 0 of multiplicity 2. It would have shown up twice as an answer. It's an even number. And 0 is a 0 of the function of multiplicity 1. It only showed up 1 time. The power on 2x was 1. All right, so it has a multiplicity of 1, or an odd number. Here's where the multiplicity comes into play. If the multiplicity of an x-intercept is an even number, then our graph will touch and turn at that x-intercept. If the multiplicity of that x-intercept is an odd number, the graph will cross through that intercept.